Now we'll see problem. When 3 alpha particles are combined to form a C12 atom, then what is the energy released in the process given mass of alpha particle, that is helium nucleus, is 4.002603 and mass of C12 atom is 12 atomic mass units. So this is the problem. 3 alpha particles are combined to form a C12 atom. You are asked to determine what is the energy released during that process. Okay, given the mass of helium nucleus, that is alpha particle, and also C12 atom mass is also given in the problem. Now we will see the solution part of it. See, first of all we will try to find out the total mass of 3 alpha particles, and then we will find out the mass of C12 atom. We will take the difference between them, that is mass defect, that will be multiplied with C square, that will give you the energy released in the process according to E equal to mc square principle. So here mass of each helium nucleus, that is given as alpha particle mass, is given as 4.002603. So there are 3 alpha particles. For 3 alpha particles, that will be 3 multiplied by 4.002603. That will give you 12.007809 AMU. Right? That is the mass of 3 alpha particles. Next, the mass of C12 atom, this is 12 AMU. So the defect in the mass, or mass difference delta M, is given by this minus this, that will give you obviously 0.007809 U. Next, we know that for each 1 unit AMU, atomic mass unit, when you convert this into energy according to E equal to mc square principle, we will get about 931 million electron volt. With that, we need to calculate the energy corresponding to this much of AMU. So obviously the value will be 0.007809 multiplied by 931 million electron volt. That will give you 7.27 million electron volt. So that is the answer. That is when 3 alpha particles are combined to form a C12 atom, the energy released in that process is 7.27 million electron volt.